Welcome students. Let us continue our discussion with the topic impulse momentum equation or impulse momentum by solving some more examples. The next question says a 200 kg package is being pulled up by a cable powered by a motor. For the short time, the force in the cable is F is equal to 1200 T square Newton. So let me write here also F is given to us as 1200 T square Newtons. If the package has the initial velocity of 3 meter per second at time t is equal to 0. So this package is moving with a velocity of 3 meters per second. Find its velocity at time t is equal to 2 seconds. The coefficient of friction is 0.2 between the package and the incline. So coefficient of friction for this particular plane is mu is equal to 0.2. Now, before applying the impulse momentum equation, we need the forces in x and y direction, and for which I will need to draw the free body diagram. So starting with it, so we have the package here. The first thing which we show in the free body diagram is the applied force. I will show here applied force, which is given to us as 1200 T square. Next is self weight. We know that self weight acts vertically downwards, and the value is given to us is 200 kg, so it will be 200 into 9.81, converting into newtons. Next will be reaction from contact surface. So yes, as this package is in contact with this inclined surface, this surface will exert reaction towards the package. Let it be N. And the last force will be the friction force. As the package is moving towards upside, the friction force will be towards downside with a value of 0.2 multiplied by N. With this we have completed showing all the forces on free body diagram, but this particular force, if I consider this as my axis, this is my x and this is my y, this particular force of 200 into 9.81 is the inclined force. So resolving it into x and y components, I will get the values as 200 into 9.81 cos 30, because this angle will be 30 by geometry, and this force will be 200 into 9.81 sin 30. Now we can apply impulse momentum equation in x and y directions. So let us start with impulse momentum equation in y direction. Again I will write a formula, mu plus impulse is equal to mv. In place of impulse I can write f into t. Now as I am applying momentum equation in y direction, I will write here muy plus fy into t is equal to mv. Okay, let us start substituting the values which we are knowing. So mass is given to us as 200. Initial velocity in y direction will be 0, because you can see that this block is moving along x direction if we refer to this coordinate system. So y is equal to 0 plus summation of forces in y direction. So summation of forces in y direction will be n going upwards positive minus 200 into 9.81 cos 30, which gives the value of 1962 cos 30, multiplied by t should be equal to 200, that is mass, multiplied by again velocity in x direction is 0. So on solving this I will get the value for n as 1699.14 newtons. Now let us apply impulse momentum equation in x direction. So when I apply impulse momentum in x direction, again I will write the impulse momentum equation, which is mu plus impulse is equal to mv. Substituting impulse as f into t, I will get mu plus, now observe here, as we are given force in equation form, that is force is in variable with respect to time, hence the formula will be integration between the limits t1 to t2 f dt is equal to mv. So as the force is varying along with time, the value of impulse is given as integration between time t1 to t2 f dt. Mass is given to us as 200. Initial velocity was given to us as 3 meter per second. Let it be u because it was initial velocity, plus integration between the time limit 0 to t2, because we need the answer at time t is equal to 2 seconds. F, considering all the forces in x direction. So forces in that direction are 1200 t square going right side positive, then this force 200 into 9.81 sine 30 going left side, which will be negative, so it is here minus 1962 sine 30, minus this zero point 0.2 into n. So 0.2 multiplied by n value we have already found out in this equation, which I am substituting here, multiplied by dt is equal to m multiplied by v, which we need to find out. So on solving this, I will get equation as 600 plus the integration of t square is t cube by 3, so I will write 1200 t cube by 3 minus 1321 t within the limits 0 to 2 is equal to 200 v. And on solving this equation entirely, I will get the answer for v as 5.79 meter per second. So we were asked to find its velocity at 2 seconds. So our answer will be the velocity of this block at 2 seconds will be 5.79 meter per second. And this completes the solution. Thank you.